But let's go ahead and introduce our speaker. Frank has, for the past 20 years, been working in the water area. He specializes in commercial pools, large-scale industrial construction, petrochemical, and municipal applications. He's a CPO and a former CPO instructor. He's a certified professional in erosion and sediment control, dealing in wind and rain erosion prevention and sediment control for multiple industry sectors. Frank also is a certified commercial building energy auditor at the level 1, with freshwater sources high variability due to weather and discharge loads associated with human activities, further affecting water quality. Frank has created a specialization in understanding the economics that water-related issues cost clients. Frank has a bachelor's in economics from the University of New Mexico and a master's in business administration from Webster's University, and he's a local, folks. He's from Scottsdale. So please welcome Frank Kneib.
Thank you, Wayne, for that introduction. Well, on the presentation that was available, if it was hard to read, if anyone wants to come up and get a copy of that later on, let me know after, and I'll be sure that you get that. So I am a certified pool operator. I'm very proud of that, and taught a lot of people throughout my years. The industrial sector is where I spent the last 8 to 10 years and really enjoyed all the learnings that came from wide variety of industries. So today we're going to talk some of the practices on water efficiency, water reuse that are available in the rec water industry, some technologies that are available. We're going to show you some examples of industrial applications and how we might apply that to the rec water industry. We're going to talk a little bit about the water energy nexus and why, saving water at both can both apply to energy savings, but vice versa, energy savings can save water, both in a region, nationally, even globally. And then at the end, I've got some handouts if someone's interested in doing a self-audit of their facilities. You can come up and help yourself. So we always start with water chemistry. It's the heart of the sanitization, the safety of the system. But when I'm looking at design or redesign, I like to take in all the factors, both in the water balance, but looking at nutrient control as a hidden mechanism for bather load, for load. And I'll show you an example in here where just doing some nutrient control, we can actually get improved water quality. Another example is just the load that puts on our disinfection, and either that be a biofilm or whether that be just an algal bloom. These can have significant drawdown on our primary sanitizer. And then looking at the TOCs, the whole TOC gamut, and how that affects the disinfectant and, again, the health of our water. So I'm going to show you, a lot of the different sanitizers are out there. And when I'm looking at a redesign, I want to know the advantages and disadvantages of each of the different sanitizers, because for different regions, different things make sense. And I've even used co-sanitization, trichlor bleach, for example. We can minimize some of those negatives and maximize the throughput, both the disinfectant capability, but also reducing the water change that we have to do. So again, just some more of the sanitizers that are out there. And when we're talking about oxidizers, there's the standard monopersulfate, ozone, the standard sanitizers, UV, chlorine, all have ozonating or oxidating capabilities. Using, some industrial available chemistries like peroxides and mixed oxidants can help us with the bioload that's coating the biofilms in our filters and our piping, and that can have a significant effect, again, on the disinfectant level. Chemical automation, in my mind, I don't know why any facility doesn't have it. The capabilities of going out there and testing routinely based on a routine beta load at a commercial facility, you just don't get enough data points to make the accurate corrections. So I'm a big fan of automation, both on the disinfectant and pH, but also on the backwash cycle. And we'll take that a step further when we talk about energy efficiency and how automation can be utilized there. But I will say that, having been an operator and an instructor, you cannot replace that trained operator. That's essential in the day-to-day, because all the equipment and the chemistry in the world in the proper hands is very effective. In hands that don't know what they're doing can be very dangerous. So, the pump is our heartbeat of the system. It's what drives all of our energy. There were talks earlier today, we're talking about, Energy Star rating, and I would put that as a minimum. And when you're looking at any design or redesign, Energy Star ought to be the ground floor. Proper sizing. We can take two pools designed almost identical, and they have completely different personalities. So, we need to not only just look at the specs, the model health code, those are all good parameters, but there's also some professionalism in understanding the load of the environment. You can have a multi-housing that has 3 identical pools, and 2 will get heavily used and 1 won't get used at all. So again, that comes back to that trained operator, being able to adjust, make modifications in the operation side. VFDs, variable frequency drive, is one of the topics that was discussed earlier. It's very big in the industrial space, being able to control and modify the power load that we're sending to a pump. And that really can cut both the total energy draw, but it can also cut the peak. And most billing, especially out here in Phoenix, we have a very high peak demand price, both residentially and commercially. And versus the off-peak hours, it's about 1/4 the cost. So being able to trim your peaks so that you're not getting billed at such a high rate can save money to the operational side of your business. But it can have tremendous effects when we're talking about the water energy nexus and how peak trimming can save a lot of water as well. Devices like magnetic coupling, shown there in the top right-hand corner, you don't have a direct connection between the impeller and the motor. So you have a slip, and that event, again, helps you with your soft start so that you don't have that excess load draw. Now, some of these things, we're talking about, when we're talking about pumps and retrofits and VFDs, we've got a circulation system, and we've got health codes that we've got to meet. But there are other areas. There's so many interactive features out there today that use booster pumps. Booster pumps are not regulated on that front, so we can trim those. From a complete shutdown to a very low flow rate. So that can all be adjusted to maximize your efficiency, but also minimize the run cost and the load on the system. Load capacitors, where we have capacitors on pumps, but we can also put a capacitor at the load by the to the whole system. So we actually have some storage capacity to minimize peaks. Lots of different types of filtration. Again, designing the filtration or retrofits to the filtration should be made with the whole system in mind. So, we were talking this morning at breakfast, a 100,000 gallon pool in Las Vegas has a completely different load than a 100,000 gallon pool at a residential or at a multi-housing. And so, a 6-hour turnover doesn't apply equally. You may, for a high bather load, high use, you may need to go to a 2 or 3 hour turnover design. But we can do that and not overload the power usage through a combination of energy saving, energy efficiency models. And then the other thing that want to expand upon is thinking about recovering your backwash. And if we're not having to backwash, so in the example of a regenerative filter or a cartridge or filter, we don't have a backwash. We have different considerations. We have man hours, and we need to balance all those things and do the calculations. But if you are using a backwashable filtration, is there ways to recover that backwash and reuse it in the system? So heating, we've got a wide range, more than we've probably ever had, and a lot more efficient than we've ever had. Whether that be solar or PV, using the big facilities boilers to heat the pools. The cost of natural gas has really, with the production nationally, that's really improved the economics of natural gas. But photovoltaic has improved the cost of electricity. And so, again, we need to take all those considerations when we're doing any kind of retrofit or new design. So looking at ways that we can, through operation, reduce water usage. The simple things, leaks. We can control leaks. Splash out, not so much, right? But I know a lot of facilities, when I was working in Vegas, they were doing blowdown every day. They're constantly draining water off the system. And they would drain their entire pool volume annually. That's a lot of water loss. When these go to municipal sanitary, sometimes that's fed back and made into potable. Sometimes it's groundwater injected or infiltrated, but a lot of times it just goes to surface water. And that water is lost out of that region many times. So just having a bigger perspective on water efficiency and ways to deal with that. Again, mentioned, looking at filtering without a backwash or without that loss of water. one of the things with evaporation is, there's things that we can do. And I'll get into them more, but just misting systems. Phoenix has had, historically, we've had a lot of misting systems, and that actually can have negative effects on the environment, both from a water loss perspective, but also from a climate change. And we can actually increase the ambient air moisture when there's enough misting systems. But when we have high winds, you don't need misting systems because you get cooling effects through the wind. So the other thing is, when we're talking about VFDs, and that's smart technology, working with the grid to optimize our energy, we can put other inputs into that. So again, wind might be a way to, if you've got a play feature that's got fountains and whatnot, we can put the VFDs and control that down so they're not, the splash pads and whatnot aren't as high. You reduce evaporation in that way as well. So one of the things that when I've done these, you want to put out there publicly that you're doing these things, because as a parent, if the splash pad's not as interactive, I might be disappointed. The kids might be disappointed. So, but by putting out a policy where you're showing that you've got a water savings initiative, they already are expecting in high winds for those features to be reduced on the water usage. So, no filter is perfect. Everything has its advantages and disadvantages. Again, just kind of, when I started in the industry, the regenerative filters were not as far along as they are. Today, they're a lot better. So, taking a redesign, and everyone here is here because we're trying to make a difference and learn, and it's good to look at the new technologies. Automatic pool cleaners, help with dead spots. They are going to draw more power. They do have the problem that you can't have them in all the time. They can only be non-operational hours, but they can certainly help with the recirculating system, and the ones that have filtration on board, is 2 microns and whatnot, and that certainly is going to reduce the load on your primary system. So again, that can have effects on how often you have to backwash that system. So, from a flocculant filter aid perspective, we have, all different types out there. They all kind of have their pluses and minuses. Give you an example of next of how you can kind of take chemistries and reduce some of the negatives and increase some of the positives. So here was just an example of some work that I was involved with, and we could see that both we can get better clarity with certain types of technologies, but we can also, if you're getting clear, you're thinking normally that you're going to load the filter faster. But what we saw was we were actually getting higher flow rates than you would expect. And so better water quality, but without sacrificing the filter turnover rates and thus the backwashing cycle, the loading rates on the filter. So this was some work that I was doing in Southeast Asia. This is a 300 million liter a day drinking water facility. And we worked on a hybrid. It was a biopolymer and a metal coagulant. And by utilizing those two technologies, we were able to get the best water quality going into the plant. So they were suffering from both dry weather and wet weather issues. Algae in the dry and high sediment loads in the rainy season. And this allowed us to get significantly better throughput without the same backwash. And when they're backwashing, they, at one time, were just dumping right back into the river. Regulations finally prevented them from doing that. But, you can imagine backwashing filtration on a 300 million liter a day tank. There's a lot of backwash storage there. And so just kind of thinking outside the box sometimes when it comes to the chemistries and looking at the advantages and disadvantages and trying to optimize. So I mentioned nutrient control. I've done big aquariums and zoos all over the world, but this was just a backyard that had no sanitization, just had a koi pond, a 1,200-gallon koi pond, and the owner had said he couldn't tell he had fish because he couldn't see, unless they broke the surface, he couldn't see them. And filter cleaning 3 times a day. And just by stripping those nutrients, using an anionic flocculant to bind up that precipitate, he got it down to where he could see, to the bottom of the exhibit, which was 2.5, 3 feet, but probably realistic depth was, 10 feet. And got filter cartridges cleaning down to once every 3 weeks. So, just that nutrient load can have a big impact on sanitizer, loading, backwash, from a water efficiency standpoint. So covers, solar covers, thermal blankets, these can certainly reduce evaporation and water loss. The energy that we put into heating that water, it can help with the indoor air quality. Some considerations. Can we shut off the facility and limit access for a safety reason so that we don't have anyone possibly falling in to the body of water when it's not open? Oxidation. These are all considerations when we're looking at a facility. So other types of covers, safety covers, a little bit more breathable. Typically these are going to be more of a seasonal application, not a daily or an operational thing. But they will reduce evaporation, and again, can help reduce any air quality indoors. So structures, whether this be a permanent structure, natatorium, or temporary structures, definitely can help save with water evaporation, heating. I do like the idea of having the ability to open it up and vent it. I've done a lot where early mornings, indoor facilities would open up the doors and put fans and blow it outside just to help with the oxidation. So there's, a capital investment that you got to consider, and the indoor air quality and then whatnot. But things, just another tool that we have in order to reduce our water usage. We have chemical covers. We can actually, add chemistry to the water to reduce that evaporative loss. You've got, some advantages here in terms of capital. There is some capital inlay to for the chemical, but you don't have the capex side of that investment. Great paper there at the bottom talking about evaporation and using these type of chemistry for water loss prevention in our surface waters, mainly drinking water, lake applications. So there's some research that was showing, and you look, the entire segment had almost a 20% savings in water loss. So, that's a pretty significant amount of reduction in water usage, and I guarantee people in California, Arizona, Nevada, all over the Southwest that's going through drought right now, they're considering every angle to save water. So I'm going to give you a couple examples that I've seen and dealt with in the industrial sectors. So this is a backwash recovery and makeup system at Discovery Cove in Orlando. They're making salt water, so they're inland, so that they have to make the water. They have to make the salt water, and they can't discharge salt water. So it's a completely closed system. So they had to be very efficient in their water recovery and recycle. So starts with backwash basin. All the backwash goes in. They were adding a series of flocculants to help settle out those particulates out of that water. Oops, wrong way. The sludge was drawn off the bottom. It's a cone bottom. So the sludge is all drawn off and stored in a sludge tank. This clean water was transferred into the makeup tank. They did have a bank of filtration that they could run it through to, if they needed the filtration to get the water quality to where they needed for putting back into the system. The original design didn't have any chemistry in the backwash, and so they were filtering every time they were transferring the water. And when we went and added the flocculant drop down and we were getting the water clarity, it reduced the filtering needs on this system. Here's a frac sand mining and aggregate mining operation. Here they're just using simple pondage. So they wash the aggregate. Those particulates get injected. You see it coming into the main pond there. And we're using some chemistry, able to drop out that particulate. That's picked up at the far end and reused in the system. So, here they have land, they can use pondage. Other times you may have to add filtration if you don't have the same space. You can enhance the separation and clarity with filtration. Here's ready mix concrete. These facilities would have anything from storm water to wash water that when they wash all the trucks in, when the cement trucks come back or the concrete trucks come back, they wash them out, they wash the exterior. All that water just collected on site. And you can see the basins there, just simple tapered basins that overflow at one end to the next. And by using a combination of flocculants, acid, we're able to get that water to where they could discharge it, or whether they could reuse it back in the making of concrete or back into the wash systems. So we were reducing the amount of water that they're having to bring on site. And especially when you're dealing in, stormwater, where you've got to have a certain amount of capacity in order to meet regulations and permits, any excess water that you're bringing on through process reduces your capacity on site. So here we were able to, optimize the system through through some chemistry, just some flocculants and acid. So how can we take kind of industrial recycle examples and apply that to the rec water industry? So, commercial facilities have stormwater permits, air quality permits. A lot of stormwater design today is built to at least capture and reduce the amount of runoff to prevent flooding and prevent bacteria, heavy metals, hydrocarbons being discharged into the environment. And so we can hold that water. You go around Phoenix, you'll see all the stormwater basins are just holding areas, and it'll evaporate or it'll infiltrate. But we can actually capture that and through stormwater vaults and be able to use that water for irrigation, flushing toilets, any number of recycle applications. Theoretically, if you want to, you could clean that. And they're taking wastewater and making potable water out of it. We can take stormwater and make pool water out of it if we need to. But that's probably not the most efficient, economical model. But irrigation, gray water, these are very viable options for that. This is a little example that I've used at my house for a number of years. I have a DE filter, can't backwash into sanitary, and so I just built a backwash basin. My kids made me turn that into a little fort, but a very simple construction for the backyard, and just add a flocculant during the backwash cycle, and I can recover and just use siphon action to transfer that clean supernatant back into the pool. From a commercial perspective, we've got to worry about if we've loaded up the biologicals, bacteria, into that filter, we don't want to recover, highly polluted water back in. So we may, on the industrial side, add some hyperchlorination to just that water, or other, advanced disinfection technologies to treat that water specifically. But certainly thinking about how do we take industrial, water recycling and just be able to reuse that. And I reuse 95% of the water from my backwash. So significant reduction in water usage. Mm-hmm. So what is a water energy nexus? And lots of stuff out in publications, but in essence, it takes water to make energy, and it takes energy to move water. And so there's a high correlation between the two. And so by saving water, we can save the amount of power, which saves water at the power plants. This is some research that I've done. Our two biggest users are ag and power plants. Use the most fresh water across the country. Right there, 4.7 billion gallons a day is used for power at coal, oil, natural gas, and nuclear plants. So the 90% of our power comes from those types of power plants. Very large water volume. Wind, PV, some of the greener technologies, they don't have that water usage at the point of generation. Now you may have water usage for when it goes back onto the grid, you got a cooling system for storage, whatnot. But at the point of generation, point of creation of that power, we don't have that water usage. So thinking, more in a broader perspective from a power and water usage standpoint. And this fact a little less than 6 gallons of water is needed for every kilowatt hour that we produce and use. And that's, just taking a typical 15% savings. And I do a lot with energy efficiency, and pretty much everyone's at least 15%. You can save enough on a household to basically save about 10,000 gallons of water. So my 11,000 gallon pool, just by trimming my energy, I can save that amount of water. Things like PV, again, you're not generating the power with the water demand. You can save up to 65,000 gallons. So it was eye-opening to me in doing that research to be able to get that kind of volume of water savings. So on the energy efficiency side, again, things like load capacitors, peak trimming, LED lighting, HVAC additives that you can make your HVAC run a lot more efficient, reducing the friction, looking at the building envelopes. So we've got our pump rooms, but we've also got buildings a lot of times on property that are associated with that. So looking at the entire energy consumption on the facility and looking for ways to utilize energy efficiency, energy generation in a whole new realm. I've been in pump rooms, even in the wintertime, are sweltering. That's heat. We can use that heat, cogen, and be able to utilize it someplace else where we need that. Okay. One thing with the variable, with clean energy like wind and solar and biogas, we have variability to it that we can't account for. And so tying that to the grid, they've got to account for that excess. If we're producing excess, they've got to account for it. And so, I'm a big proponent of trying to bring your production and your energy storage closer to the point of usage. And that helps reduce the amount of excess that the grid has to compensate for. When I first looked at PV for my house 7, 8 years ago, it was 65 grand. Today, that system's half that. So the technologies are improving. So even if you've tried penciling something out in the past, maybe re-looking at it, because they're just getting more and more economically efficient as we go on. So again, I mentioned up here I've got some evaluation forms. If you want to get one of these, if I happen to run out, let me know. I'll email it to you. But I condensed it all into one handout. But just gives you a chance to kind of go back to your facilities or your region, and it's kind of a checklist of things to look for. Things that I would look for if I was doing a property walk. Again, just kind of more specifically looking at water efficiency and the power. The two are able to bring that together. So, kind of in summary, I'm so excited about the model health code and the way that they're trying to centralize data collection. I think benchmarking, is things we do in the energy auditing, but we can apply those kind of principles to water efficiency, energy, and actually be able to maybe even add that into a LEED certification. There's lots of areas that this is going to evolve over time. And I appreciate you guys' time and attendance today.
Great, thank you, Frank.
Thank you.
Any questions from the audience? Oh, good, one.
So I hadn't heard about the use of chemicals as, I guess, whatever the solar, I know it wasn't solar blanket, some kind of blanket, right? Where, you know, chemical blanket. Yeah, I hadn't heard about that before. So is that used, like when would you use that? Are people actually using the facility? People are swimming?
Yeah.
So what's it feel like to swim in hexadecanol?
And it's just, they're basically alcohols. So as you splash, it just moves. So you do lose some efficiency in terms of a stagnant surface. You've got surface tension. That helps reduce evaporation. When you splash, you know, you're losing some of that surface tension, and therefore, you know, that's one of those downsides of that technology is it's not going to be as efficient as obviously a cover, a hard cover, or a structure. But, you know, from an implementation standpoint, it's a lot easier. So, yeah, there's, you know, several products on the market.
Right, they've been around in the industry for quite a while. Yeah, and they're one of the brand names I think was called Fish, P-H-I-S-H. It came out a while ago, but yeah, they're exactly as Frank described. Anyone else? Excellent. Well, good. Like Frank said, he has additional copies up here at the table along with his business card. If you'd like to come up and take a copy, please do so. Next session will start at 4 o'clock. Thank you all. Appreciate it.